All right, here is number 10 on the 1.3 to 1.5 test review. It took a rowing crew 2 hours and 40 minutes to row 6 kilometers upstream and back again. If the rate of flow of the stream was 3 kilometers per hour, what was the rowing speed of the crew in still water? Okay, so this, I'm going to read this as saying 6 kilometers going upstream and then 6 kilometers coming back. So we're going 6 kilometers up and 6 kilometers back. And 2 hours and 40 minutes. We need to convert that to hours only because we're talking about rate here for 3 kilometers per hour. Uh, as far as speed, the 3 kilometers per hour is for the stream, sorry. So we've got 2 hours and 40 minutes. That's 2 and 2/3 hours, which is 8/3. So now that is in hours, 8/3. We are going to, um, because we have a definitive distance going there and also back, we have a definitive expression for rate because in still water, if we consider our rate to be R, going upstream, the water is pushing against us at 3 kilometers per hour. So it's going to slow us down. So R minus 3. And for downstream, the water is pushing us to go faster, so we're going to have R plus 3. We don't know how to split up the time. So we're going to leave that as its own individual value. This is a distance equals rate times time type of problem, but we want to represent this based on time. So we're going to divide by R and have time equals distance over rate for the segment going upstream plus the distance over rate for the segment going downstream. Because if time can be represented by distance over rate, we have our time going upstream plus our time going downstream to equal our total time. Okay, so that's how and why that gets set up the way it is. So we're going to have 8/3 equals 6 kilometers going upstream, and that's going to be R minus 3, plus 6 kilometers going downstream, so R plus 3. And I know in class I went 3 and 3 because I read that to be 6 kilometers total for there and back, but now I'm reading it and it says 6 kilometers going upstream and then back again. So I'm going with 6 and 6 in my example here. So now I have to multiply by a common denominator, and that is going to be 3R minus 3 and R plus 3. When I distribute over to the first fraction, the 3 cancels out, and I'm going to be left with the R minus 3 and R plus 3 to go with the 8. When I distribute to the second term, the R minus 3 gets canceled out. I'm left with 3 and R plus 3 to go with the 6. And when I distribute to the last term, the R plus 3 cancels. I'm left with the 3 and the R minus 3 to go with that 6. Now I'm going to multiply, distribute, and clean this up. R minus 3 times R plus 3 is R squared minus 9. And I'm going to distribute the 8, and I get 8R squared minus 72. Here I have 18, and when I distribute, I am going to get 18R plus whatever 18 times 3 is. Let's see here. 18 times 3 is 54. And then we have 18 again. We're going to distribute, and we will get plus 18r minus 54. The 54s will cancel each other out. 18r plus 18r is 36r. And now I have a quadratic here, so I'm going to subtract 36r. And I get 8r squared minus 36r minus 72 equals 0. Now if I want, I can divide all of these by 4, and I will get 2r squared minus 9r minus 18 equals 0. And then I can solve this using the quadratic formula. A equals 2, B equals negative 9, C equals negative 18. So I'm going to have x is equal to 9 plus or minus the square root of negative 9 squared minus 4 times 2 times negative 18 all over 2 times 2. When I multiply or simplify the inside of the radical, I will get 225. And I get 9 plus or minus the square root of 225 over 4. The square root of 225 is 15, so I will get 9 plus or minus 15 over 4. I'm going to split that up, so 9 plus 15 over 4, and 9 minus 15 over 4. 9 plus 15, that's 24 over 4, which is 6. 9 minus 15 is negative 6 over 4, which is a negative speed, which is not possible. So 6 kilometers per hour is our speed. Okay, looking at let me look at here something. Maybe I have more down below. Nope. Interesting. I am missing part of 1.4. Okay, so here's number 11. Kim drove to Rockford to Springfield and back. So Rockford to Springfield and back to Rockford. So her average speed on the way back to Rockford was 5 miles per hour faster than the way down to Springfield. So if we say our rate going down to Springfield is r, then our rate on the way back is r plus 5. If the total trip took 8 hours and 20 minutes, what was her average speed going down to Springfield? So we have a total distance of 520 miles. So that's 260 miles going down and 260 miles coming back. So again, we don't know how to split up our time. We are able to split up the distance equally, and we have our rate represented with r and r plus 5. So I'm going to set this up just like the last problem, where I'm going to have my time is equal to the distance over rate for going down to Springfield and adding my distance over rate for back to Rockford. Okay? So my total time, 8 hours and 20 minutes. I need to convert to hours only. That's going to be 8 1/3, which is 25 thirds. So 25 thirds is going to equal to my distance down, which is 260, over my rate, r. Plus my distance coming back is also 260 over my rate coming back, which is r plus 5. Now I have an equation to solve where I've got denominators, so I'm going to multiply by the common denominator of 3 times r plus 5. When I distribute to the first term, the 3 cancels out. I have the 25 that's in the numerator, the r, and the r plus 5. In the second term, when I distribute, the r will cancel out. I have the 260 that was up there already, my 3, and the r plus 5. And when I distribute to this third term, the r plus 5 will cancel. I will be left with 260 and the r, 3r. So now I've got this equation to solve. I'm going to distribute 25r, and I'm going to get 25r squared plus 125r equals 260 times 3 is 780. So 780 times r, because I'm going to distribute that, and 780 times 5 is 3,900. And over here, I'm going to have 260 times 3, which is just 780r. Okay, I've got a quadratic, so I'm going to get everything over to the left-hand side and set this equal to 0. Since 780r plus 780r is equal to 1560r, I'm going to subtract 1560r from both sides. Subtract the 1560r from the left side, so that will cancel out both of these 780s, 780r's. And I also need to subtract 3900 from both sides. Okay, so I've got 25r squared. I've got plus 125r minus 1560r, which is going to give me 1435. So minus 1435r minus 3900 equals 0. All right, so that's r. It's a quadratic, so I need to use the quadratic formula. I could divide things by 5. That would give me 5r squared minus 287r minus 780. So at least I have smaller numbers to work with for my quadratic formula. So x equals 287 plus or minus the square root of negative 287 squared minus 4 times 5 times negative 780 all over 2 times 5. When I simplify the underneath part of the radical, I will get 287 plus or minus the square root of 97,969 over 10. The square root of 97,969 is 313. So I will get 287 plus 313 over 10, and I will get 287 minus 313 over 10. 287 plus 313 is 600, and you divide that by 10, you will get 60. Over here, when you subtract, you're going to get a negative answer, so that's not going to count because you cannot have a negative rate. So 60 miles per hour is her speed for R, and R represents the rate going down to Springfield, which is what we're looking for. So 60 miles per hour is our answer. And that's it for this video.